My name is Dr. SB Wayah, and on this channel, I explain the concepts of biochemistry and biotechnology in a simple and practical way. In this video, we are going to learn how to calculate the isoelectric point of amino acids that have ionizable side chains. To demonstrate this clearly, we will use lysine as an example. By the end of this video, you will understand the logic behind the calculation, and you should be able to apply the same logic to other amino acids. Before we begin the calculation, let us understand the meaning of isoelectric point, or PI. The isoelectric point of any given amino acid is the pH at which the amino acid has a net charge of 0. At this point, the amino acid exists as a Zwitter ion. This means that it has a positive charge and a negative charge. However, the net charge of the amino acid is 0. Understanding isoelectric point is important because it influences protein solubility, protein purification, and electrophoresis behavior. Some amino acids have side chains that can gain or lose protons depending on the pH of the environment. Such amino acids include lysine, arginine, histidine, and glutamate. Because of the presence of these ionizable side chains, these amino acids usually have more than 2 pKa values. Let us now look at the pKa values of lysine. Lysine has 3 ionizable groups: the alpha carboxyl group, the alpha amino group, and an extra amino group in the side chain. Each of these ionizable groups have different pKa value. The pKa value of each ionizable group represents the pH at which they lose a proton. To understand how to calculate the isoelectric point of lysine, we must observe how the charge of the amino acid changes as pH increases. At very low pH, lysine is fully protonated, and that means it has a net charge of +2. When the pH reaches the first pKa value, it ionizes and the net charge becomes +1. By the time the pH reaches the next pKa value, which is the second pKa value, another ionization takes place and the net charge becomes 0. And when the pH reaches the third pKa value, the third ionization takes place and the net charge of lysine becomes -1. The key rule to calculating the isoelectric point of any given amino acid is to identify the 2 pKa values that surround the neutral form of the amino acids. After that, calculate the average of the 2 pKa values, and that will give you the isoelectric point. For lysine, the 2 pKa values that surround the neutral form are the pKa 2 and 3. When you calculate the average of these 2 pKa values, you will get the value 9.75, and that's the isoelectric point of lysine. A very useful shortcut is, for basic amino acids, the PI is usually the average of the 2 highest pKa values, while for acidic amino acids, the PI is usually the average of the 2 lowest pKa values. And now is your turn. Using the same approach, calculate the isoelectric point of histidine. Write your answer in the comments. I'll pin the correct answer later. If you found this explanation helpful, please like the video and subscribe for more lessons on biochemistry and biotechnology. Thank you for watching.